and square root. First question, find the greatest number of 6 digits which is a perfect square. We need to find the largest 6-digit number which is also a perfect square. In order to find that, let us find what is the largest 6-digit number first. We all know that the largest 6-digit number is nothing but 9,99,999. This is the largest 6-digit number. So let us take this number as dividend. So taking this number as dividend, we can use long division method. We can find a remainder. If we subtract the remainder from the dividend, means we get the largest 6-digit number which is a perfect square. So this is the number 9,99,999. So in order to do long division, we need to divide them into pair from right to left. So I'm dividing this into pairs. So dividing this, we need to take first two numbers. What is the first two? 99. 99 is not a perfect square. So let's find the perfect square below 99. We know that 9 nines are 81. So subtracting these two, we get 8, 1, 18. Let's bring the next pair. 1, 8, 9, 9. Here 9 plus 9, 18. So next, let's find the largest number. So let me put 9. 9 nines are 81. Balance 8. 9 eights are 72 plus 8. 80, again 8. 9 ones are 9. 9 plus 8. 17. 1701. So let's subtract these two. 8, 9, 1. Let me bring the next pair. It is 9, 9. Here it is 9, 9. So adding with 9, we get 18 balance 1, 9. 198. Again I am going to multiply with 9 into 9. Multiplying we get 10971. It is 17,901. Let's subtract these two. So subtracting we get 8, 9, borrowing 8, this is 18, 9, 1. So we get remainder as 1998 and this is the dividend. In order to find the largest 6-digit number, we need to take dividend. What is the dividend? 9,99,099. So the formula is dividend minus remainder. So dividend minus remainder is 1998. So subtracting these two, 100899. So the largest 6-digit number which is also a perfect square is 9,98,001. So this is nothing but a square of 999. So 999 whole square. The answer is 998,001. This is the final answer. Let's go to next question. Find the least number which is perfect square and which is also divisible by 16, 18 and 45. So we need to find a number which is divisible by 16, 18 and 45. And also that number must be a perfect square. In order to tally these two things, we need to find the LCM of these two numbers and we can find the multiple of that LCM. I'll tell you the reason why. Because if we find the LCM of this number, means obviously all these three numbers are divisible by that LCM. And if you are going to find the multiple of LCM, means definitely if LCM is divisible by a number, means the multiple of LCM is also divisible by the same number. So let's check whether the LCM is a perfect square or not. If the LCM is not a perfect square, means we can go with what number must be multiplied in order to change it to a perfect square. So we can go with that concept. So let's take the LCM. 16, 18 and 45. So for doing LCM, let's go with prime numbers. So 2 table, if I use 2 table means this is 8 times, this is 9 times, and 45 doesn't come in 2 table. Let me stop with 45. Now I can use 3 table. If I use 3 table means 8, this one is 3. So 1, remainder 1, 15 times. Again I can use 3 table, 8, 1, 5. Now I can use 5 table. If I use 5 table means this is 8, 1, 1. Let me use 2 table. This one is 4, 1, 1. Again 2 table, 2, 1, 1. Again 2 table, 1, 1, 1. I'll tell you why we use the prime factorization in the last step. Now let's go with the LCM. So LCM is equal to 2 into 3 into 3 into 5 into 2 into 2 into 2. So multiplying all these we get 720. So let's check whether 720 is a perfect square or not. This is the reason why we used prime numbers here. Because if 720 is a prime number means we can write the direct answer. If 720 is not a prime number means we can check which number must be multiplied. So let's arrange these numbers in pairs. This 2 and 2 has a pair. This 2 and 2 has a pair. This 3 and 3 has a pair. So this 5 is left out, which means 720 is not a perfect square. But we can change this into a perfect square. How we can change? So if I multiply this with 5 means obviously this one will get a pair, which means the product obtained is a perfect square. So let me multiply this by 5. 720 into 5. I am multiplying with 5 because this number will become a perfect square. So multiplying with 5 we get 0, 0, balance 135 plus 136. So 3600 is the perfect square, which is also divisible by 16, 18 and 45. So the answer is 3600. Let's go to next sum. In a basket, there are 1250 flowers. A man goes for worship and put as many flowers as there are temples in the city. Thus, he needed 8 bags of flowers. Find the number of temples in a city. So, there is a basket of flowers. In one basket, there are 1250 flowers. A man, he goes for the temple and he puts as many flowers as there are temples. Suppose if there are 10 temple means, let us take if there is 10 temple means, in each temple he puts 10 flowers. If there is 100 temple means, in each temple he is putting 100 flowers. If there is 45 temple means, in each temple he is putting 45 flowers. So thus he needed 8 baskets of flowers. From this one we can understand that the number of temples and the number of each temple is equal. So shall I write like this? I'm going to write like number of flowers. Number of flowers is equal to number of temples. Number of flowers placed in one. Number of flowers in one temple. Number of flowers in one temple is equal to number of temples. That is total number of temples. So let me take number of flowers and number of temples as x. So now it is given that flowers in one basket. Flowers in one basket is equal to 1250. How many baskets needed? 8 baskets. So flowers in 8 baskets. Flowers in 8 baskets is equal to 8 into 1250. 0, 5 8s are 40, balance 4, 16, balance 2, 1 8 is 8, 10. So how many flowers? Total flowers used is equal to 10,000. So we can tell total flowers is equal to 10,000, which is nothing but number of flowers in one temple into total number of temples, which is nothing but x into x is equal to 10,000. You may wonder how these two x came, because we have taken number of flowers in one temple is equal to x and number of temples is equal to x. So this one is number of flowers in one temple and this one is number of temples. So x into x is nothing but x square. X square is equal to 10,000. Square going this side, it becomes square root. Square root of 10,000. I can write 10,000 as 100 into 100. Inside square root, from one pair I can take one number. So x. So x is equal to 100. So in that question they have asked, find the number of temples in the city. We can write number of temples in the city is equal to 100. There are 100 temples in the city and in each temple he placed 100 flowers. Let's go to next one. Find the value of root of 1191.16 plus 70 root of 129.96. So first we need to find what is the square root of 129.96. Then we need to multiply with this 70 and add with this number. We'll get another number. We need to find square root for that number. So let me take this one first. Square root of 129.96. So we can write all decimals in terms of fractions. So shall I write this 129.96 as 12996 by 100? Because I am writing 100 means the decimal points move two places. We know that square root of p by q can be written as root of p by root of q. So this can be written as root of 12996 by root of 100. Let's find root of 12996 using long division. First we need to arrange them in pair. So arranging in pair, we get a number like this. 1 is a perfect square. 1 ones are 1. Subtracting 0. Let me bring next one. 29. 1 plus 1, 2. So we can put 1 here because 21 into 1 is equal to 21. So here 1, here also 1. 21, subtracting we get 8, 9, 6. So 21 plus 1, 22. So 8, 9, 6. Since it ends with 6, we know that 4 4s are 16. 6 6 are 36. Let me go with 4. So 2 2 4 into 4. 4 4s are 16. Balance 1. 4 2s are 8 plus 1 9. 4 2s are 8. 8 9 6. So we got the answer 4 4 8 9 6. The answer is 0. So this is the quotient we got. Quotient is 114. So root of 12996 is nothing but 114 by 100 is nothing but 10. So 114 by 10, the decimal point is 1. So moving here we get 11.4. So for root of 129.96 we get answer as 11.4. Let's substitute in the question. So in place of 129.96 we get 11.4. 70 into 11.4 we get 798, 1191.16 plus 798. So adding these two we get 0.169. 18 balance 1, 9, 1. So 1989.16 again. 1989.16 is a decimal. Let's convert this to fractions. So 1989.16 by 100. So this can be written as root of 198916 by root of 100. Let's use long division. So dividing it into pairs, we know that 4 fours are 16, 3, 89, 4 plus 4, 8. So 389, again let me put 4 here, 84 into 4. 84 into 4 is nothing but 336. So let me put here 4, 4, 3, 3, 6. Subtracting we get 3, 5, 5, 3, 1, 6. So 84 plus this 4, 88. So let me go with, since the digit is 6 here, the only possibilities are 4 fours are 16 and 6 6 are 36. If we go with 4 means 8 8 4 into 4. So multiplying we get 3536, which is very much smaller than this one. So let's go with 6. So we get 886 into 6. Multiplying 886 into 6, we get 5316. So here 6, here also 6. 5316, 0. So this is the quotient. So quotient is nothing but 446. Root of 100 is nothing but 10. Decimal point moves one place. So 44.6. So the answer is 44.6. This is the answer. You can copy down this. We'll join you soon with more sums in next video. Thank you.